Hi class, for this sections we're going to talk about implicit differentiation. So far we only see simple functions. So for example, I have y equals 2x plus 1. That's a linear function and y depends on x. Now some functions are defined by a relation between x and y. So for example, I have x squared plus y squared equals to 25. That's a circle. So you can see that we have both x and y in the function. So how do we differentiate such a function? So we can do that by differentiate implicitly. So what do I mean by that? So for example, x squared plus y squared equals to 25. By the way, um, before this sections, if you want to differentiate this particular equation, you're going to have to solve for y and then differentiate with respect to x. But this one, we're just going to go ahead and do it implicitly. So first, we take derivative on both sides. So this is what I'm talking about. Y squared equals to d over dx of 25. So I'm taking the derivative, which is 2x plus 2y. Don't forget y is a function of x. So what I have right here, after I take 2y, I still have dy over dx because of the chain rule. And we have 0 here. And then from here, we're just going to solve for dy over dx. So I subtract 2x over, and then we can just divide by 2y. Okay, let's reduce it. I get negative x over y. Okay, so for b, we have to find the equation of the tangent to the circle at that point. So the point is 3, 4. I'm just going to use those 2 points to find the slope. So the slope of the tangent line is the derivative, which is this one. So it's negative 3 over 4. And then from there, we can use the formula, the point slope formula, to figure it out. So y minus y1, which is 4. The slope, x minus x1, which is 3. And then I'm just going to simplify it. Negative 3/4 x plus 9 over 4. Okay, let's just multiply everything by 4. So what I have is 4y minus 16 equals negative 3x plus 9. All right, so let's move x over. So what I have is 3x plus 4y. 9 plus 16 is 25. So that's my equation of the tangent line. Okay, now earlier I mentioned that if we don't want to do it implicitly, we can always try to solve for 1, and then from there we take the derivative. So what do I mean by that? I'm going to solve the equation. So x squared plus y squared equals 25. Y squared equals to 25 minus x squared. And then I'm taking the square root. I ended up with plus and minus square root of 25 minus x squared. Now, the point we considered is 3, 4, which is positive. So I don't have to worry about the negative. So I'm just going to take the y equals to square root of 25 minus x squared. Okay, so we consider this definition, this function. Now, we're going to take the derivative. So what is the derivative here? Don't forget, this is 25 minus x squared to the 1/2. Okay, like I said, you want to rearrange so we can get to use the power rule. 1/2, chain rule, so negative 2x. Okay, so from here, let's simplify. So what I have is negative x over square root of 25 minus x squared. So let's plug it in. F prime of 3 gives me negative 3 over square root of 25 minus 9, which is negative 3/4. Okay, so same thing, just like solution 1, we got negative 3/4. So the equation is going to be exactly the same for the tangent line. Is 3x plus 4y equals 25. Okay, so that's how we do it, both methods. Now, it's not going to be so easy for us to solve for y all the time. So for example, this one right here, you see this one, what we have is y cubed here, and we have y here. So it's really hard for us to solve for y. So we're going to have to do it implicitly. Okay, so let's go ahead and take a look at example 2. All right. X cubed plus y cubed equals 6xy. Okay, so we're gonna find y prime. Okay, so make sure y is a function of x. So you have to take care of chain rule here. All right, so I'm gonna take the derivative. So 3x squared plus 3y squared, y prime, chain rule. For this one, what we have is product rule. So I have 6x y prime plus 6y. Okay, because that's the derivative of 6x, which is 6, and then I multiply by y. Okay, now we're gonna have to rearrange something, and then we solve for y prime. You see, we have 3, 3, 6, 6. So how about we divide everything by 3? So I ended up with x squared plus y squared y prime, 2xy prime plus 2y. All right, now we're going to solve for y. So I'm going to put y prime on one side and everything else on the other side. So what I have is y squared y prime minus 2xy prime equals 2y minus x squared. Factor out y prime. I have y squared minus 2x. And then you can just divide. So we get y prime equals 2y minus x squared over y squared minus 2x. Okay, so that's what we have for y prime. Now what I need is to find the tangent to the volume of the card. This is called the volume of the card at the point 3, 3. So what we do is we plug it in. So for part B, I have the point 3, 3. So y prime is going to be 2 times 3 minus 3 squared over 3 squared minus 2 times 3, which is just negative 1. Okay, so that's going to be the slope. All right, once again, I'm just going to plug it in. Y minus 3 equals to the slope x minus 3. Negative x plus 3. Let's do some rearrange. So what I have is x plus y, and then we have 6. So that's the tangent line. Okay. Now, what we need to do now is we need to figure out at what point in the first Q is the tangent line horizontal. So what do I mean by that? The tangent line horizontal, meaning we have the slope equals to 0. So horizontal tangent line. Okay, that means the slope equal to 0. The slope is the derivative. Okay, so we're gonna use y prime, the y prime that we found in part 1, which is 2y minus x squared over y squared minus 2x. All right, and then we're gonna set it equals to 0. So when do we get this equal to 0? When the numerator equal to 0. So imply the numerator equal to 0. Okay, so now what do we do is we're gonna substitute back in. So first I need to solve for it. 2y equals x squared, y equals x squared over 2. Now I'm going to have to substitute that y into the equation of the curve. So I just want to remind you the curve. The curve is x cubed plus y cubed minus 6xy. So I'm going to take this y and I plug it in here, plug it in here. Okay, so we have x cubed plus x squared over 2q equal 6x times x squared over 2. Let's simplify it. So we have x cubed plus x to the 6th power over 8. All right. I'm going to simplify more. So I have x to the 6th power over 8, 3x cubed, so it's 2x cubed. Okay. And let's just move 8 over. So what I have is x to the 6th power, 16x cubed. Okay. Now, x right here. So let's go back here. At what point in the first quadrant is the tangent line horizontal? So x is not 0 in the first quadrant. So I have x is not 0 in Q1. Okay. So what we have is x cubed over x cubed equal to 16. All right. Now, of course, we can just take the cube root of those. So if I take the cube root, I ended up with x equal 16 to the 1/3, which is 2 to the 4/3. Okay. Now, let's solve for y. So y, don't forget y is x squared over 2. So 1/2, that's over 2. And then we have x squared. So I have 2 4/3 squared, which simplify everything, you get 2 to the 5/3. Okay, so the tangent line is horizontal at x is 2 4/3 and y is 2 5/3. Okay, so we got the point. I know it's a lot of calculation, but the concept is straightforward, right? The derivative is the slope of the tangent line. And every time they ask you for horizontal tangent line, you just have to set it equal to 0 and solve for x and y. Okay, let's take a look at that sample 3. So same thing as sample 3, we have to find y prime. Notice that we have the trig function, so there's no way you can solve for y. So I'm going to take the derivative on both sides. And then make sure for y, we have to include y prime because of the chain rule. Okay, so you see right here on the left-hand side, I have cosine of x plus y. Now, taking care of chain rule, I have 1 plus y prime. On the right-hand side, I have the product rule. So what I have is going to be 2y cosine of x plus y squared negative sine of x. I forgot the y prime. So every time I take care of the y, I have to include that y prime in there. Okay, so y squared times negative sine of x. All right, so for this, we can just distribute. So this is what I'm talking about. Plus y prime cosine of x plus y. 2y y prime cosine of x plus, minus y squared sine of x. All right, we're going to move all the y prime to one side and everything else to the other side. So I'm just going to keep the cosine of x plus y here, and I add the y squared sine of x over. And then for this one, we have 2y y prime cosine of x minus y squared cosine, y prime cosine of x plus y. And then you can factor it out. So I have 2y cosine of x minus cosine of x plus y. All right, as you can see, we can divide, right? So y prime is going to be cosine x plus y squared sine of x divided by 2y cosine of x minus cosine of x plus y. Okay, so that's how we take care of number 3. All right, moving on to number 4. Number 4, we have to find the second derivative of this function. So let's first find the first derivative. So y prime. So I want to find y prime first. Okay, so taking the derivative, both sides, I ended up with 4x cubed plus 4y cubed y prime equals to 0. Okay, now solving for y prime, for y cubed y prime equals to negative 4x cubed, and y prime is going to be negative 4x cubed over 4y cubed, which is negative x cubed over y cubed. Okay. From there, so this is y prime. Okay. So now we're gonna have to find y double prime. Okay. Which is the derivative of negative x cubed over y cubed. You can see that we have quotient rule here. So let's proceed. Okay. Okay. So what I have is negative 3x squared times y cubed minus negative x cubed times 3y squared y prime over y cubed squared. Okay, so we can definitely simplify. So now what I need is to find y double prime. So what's y double prime? Y double prime is the derivative of negative x cubed over y cubed. So what we have here is the quotient rule. So I'm going to proceed quotient rule. So what we have, the negative, I'm just going to take the negative out because the negative, if you apply it to x cubed, is going to be quite confusing. So I just want to do x cubed over y cubed. So I'm going to leave the negative out. So what I have right here, negative, I have 3x squared times y cubed. The second one is x cubed, 3y squared, and then because of the chain rule, I have y prime over y cubed squared, which is y to the 6th power. Okay, so you can see that we have y prime here, and then we have y prime here. Right? So I'm going to take the y prime, the negative x cubed over y cubed, plug it in. So what we have, negative 3x squared y cubed minus x cubed 3y squared multiplied by negative x cubed over y cubed, and everything over y to the 6th power. Let me just remove that negative and put it right here. Okay, that's better. Okay, now let's simplify it. Three x squared y cubed minus, so we have plus 3x to the 6th power over y over y to the 6th power. Okay, if I multiply y and get the LCD, so I'm going to multiply this one right here to get the LCD. I ended up with negative 3x squared, and then we have y okay. I have is negative 3 x squared y to the 4th plus x to the 6th power, and on the bottom we have y to the 7th. That y to the 7 is because of this y right here, so together is 7. Okay. So I can definitely take the x squared out. So if I take the x squared out, I ended up with y to the 4th plus x to the 4th over y to the 7th. But what do we know earlier? We know that y to the 4th plus x to the 4th is 16. That's how we start the problem. X to the 4th plus y to the 4th is 16. So I'm going to take that and plug it in. So now we have negative 3x squared times 16 over y to the 7. So what we have is negative 48 x squared over y to the 7. And that's our solution.